Let's solve question 11.1 from the Incropera textbook. It is a fire-related question that deals with heat exchangers and fouling factors. Before solving the question, please stop the recording and read the question statement carefully. In this question, we're given the overall heat transfer coefficient of the system as soon as it gets installed, and then we're also given the fouling factors at the inner and outer surfaces of the tube after 1 year. What is fouling? Fouling is a really important phenomenon that must be taken into account when designing heat exchangers. It's really the settlement of undesired material on the surface, outer or inner surface of the heat exchanger. And it's really important because due to dirt that gets into the heat exchanger, the overall heat transfer coefficient of the system decreases with time. That is why the heat exchanger should be cleaned periodically. And this is what we're going to prove with this question. So ultimately, our objective now is to understand what U total, so the overall heat transfer coefficient after 1 year is, and compare it to the one we had at the installation of the system. Now we have to do the two fundamental steps we do for every heat transfer exercise. We are going to redraw the scenario as I did before starting the recording, and as you can see, I labeled all the important data we're given in the statement, and most important, we are going to list all the assumptions we employ to solve the question. In this case, there is only one main assumption, yet it is crucial. We are going to consider the resistance of the pipe, the thermal resistance of the pipe, negligible. Why am I saying that? As you can remember, resistance against conduction for a cylindrical system is assessed as ln, so natural logarithm of R2 over R1 over 2 pi k, where k is the conductivity, R2 is the outer radius, and R1 is the inner radius. Now, please bear in mind that in this case, we're looking at a really thin tube. So the ratio of R2 over R1 should be approximate 1. Therefore, ln of 1 is ln of something that is almost 1 is almost 0. So this can be approximated to 0. Please bear this in mind because it's going to be essential for later on as we solve the question. Let's see how we can solve this problem. Before doing that, please remember that a thermal resistance, a total thermal resistance of a certain system is equal to the inverse of the overall heat transfer coefficient multiplied by the area crossed by the heat flux. Now in this case we don't have that area, so we can just write R dash dash total is equal to the inverse of the overall heat transfer coefficient. Now what happens at the beginning? So when we install the system, we just know that R initial, so at the beginning, is equal to 1 over U initial, which we are given because it is 400 watts meter squared Kelvin over meter squared Kelvin. What happens after 1 year though? Well, in that case, we have that R total is equal to 1 over U initial, because of course the overall heat transfer coefficient for the system becomes it's still 400. However, to that we need to add the fouling factor. So we're gonna have plus RFO plus RFI. As you can see, the total resistance therefore increases. And the trick here, which is literally the most important step of the whole problem, is understanding that this whole expression is just equal to the inverse of the U total we are actually trying to find. So literally by doing that, we can write 1 over 400 watts over meter squared Kelvin plus, and then we know the other factor, 0.0015 meter squared Kelvin over watts plus 0.0005 meter squared Kelvin over watts is equal to 1 over U total. Just to be clear again, this U total is U after 1 year. Now you simply have to calculate the left-hand side of this expression and elevate at the -1 to find that U total is equal to 222 watts over meter squared Kelvin. And this should be the answer you find. Now, before actually closing the recording, I would like to make a few comments. Indeed, as you can see, the total overall heat transfer coefficient after 1 year due to fouling has almost halved. Indeed, U initial is almost equal to 2 times U total after 1 year. And this is really important because it displays how fouling is really something that must be taken into account because it extremely reduces the effectiveness and the efficiency of our system. So please bear this in mind. It is clear that fouling makes the overall heat transfer coefficient as well as the effectiveness and the efficiency of the system decrease considerably with time. Therefore, to answer back to the question, yes, the boiler should be scheduled for cleaning on the tube surfaces. Having said that, that was all from me. Please do not hesitate to contact me if you need any further explanations of the problem.